Hi, and thanks for allowing me to share our work with you today. I'm Luke Marsden. I work at the University Centre in Svalbard as a data manager as part of the Nansen Legacy project. Amongst other things, the Nansen Legacy project investigates the role that climate change is having on the northern Barents Sea, which is one of the fastest warming places on the planet. The backbone of the project are multiple research cruises into the Barents Sea, most of which have taken place on Norway's magnificent icebreaker Kronprins Haakon that you can see here. It's Norway's largest research project, involving more than 200 researchers across 10 Norwegian research institutions and a few from overseas as well. And it's multidisciplinary, involving biologists, chemists, geophysicists, engineers, geologists, and probably more. Through the project, we're all committed to the FAIR data management principles, and today I'll discuss how the work that we as data management are doing to facilitate consistent data collection and recording and publishing of FAIR data across such a large and multidisciplinary project. The sheer scale of a project makes consistent data management particularly challenging, so systems have to be designed to facilitate this. We've published sampling protocols written by the researchers for the researchers. This means that two different people on two different cruises should follow the same methods in both collecting and recording the data, if it's the same type of data. We've designed a sample spreadsheet template generator that allows a wide range of data from different disciplines to be logged in a consistent way. The fields are based on Darwin Core, which is a standard for logging biodiversity data. However, we've extended this to encompass data from all the different disciplines involved across the project. The templates have one column for each field that the user selects. They include both formatting restrictions and instructions on how to fill in each cell. They also include drop-down lists where possible to standardize certain fields. And the result is data that are much easier to deposit into a single database. And since we're using a common vocabulary for our fields from the beginning, it's much easier later to publish interoperable and therefore FAIR datasets. Crucially, each sample is logged with a universally unique ID, or UUID, which you can see as a 32-digit hex number at the top here. A UUID can be represented as a data matrix that you can attach to a label, and then you can stick that onto your sample. So by doing it this way, the physical sample and the electronic log are linked. The electronic log is hierarchical, so at a single station you might have a couple of activities. For example, some nets could be hauled over the side of the vessel. You take samples from these nets, perhaps different fish. And below that are subsamples, so if you chop one of the fish into a few pieces. Each sample is logged both with its own ID, but also the ID of its parent. And so it's clear how the data relate to each other, and one can easily navigate through the database. All the metadata are then made available for a searchable metadata catalogue on the SciOS webpage. It looks like this. And it provides an overview of all the data that's been collected. One can use the filters on the side panels to isolate certain samples or certain types of data. But also remember our UUIDs. If someone finds a sample in the freezer in some years into the future, they can scan the label and retrieve the UUID. They can enter it into the full text search in the top left, and then once they've found that sample, they'll be able to see all the metadata related to it and identify exactly what it is and who's responsible for it. It shows some fields that are required for all of the different samples and some additional metadata that's listed below. After this, we provide training and support for all of our project members on how they can create templates, how they can use their templates to create and publish datasets that comply with the FAIR data management principles. And then all the published datasets are made accessible for a single data access point or data access portal on the CITES webpage, and they all are tagged with a common Nansen Legacy collection tag. So you can find everything from the project in one place. And finally, I'll leave you with the highlights of what I've discussed. Thanks very much for listening.